This lesson is about projectiles at an angle. Let's start right off with an example. Here's a football that is kicked with an initial velocity of 36 meters per second at an angle of 50 degrees above the horizontal. First of all, let's see that when it's kicked, it follows a parabolic path. Its horizontal displacement is called the range. Its maximum vertical displacement is called the height. It travels upward for some time, and then it travels downward for some time. And as long as the projectile returns to the same height where it was launched, the time up equals the time down. That is very important. The last important thing to note is that at the highest point, the vertical speed is 0. We've seen this before. It's not going up anymore. It hasn't quite started to come down. Its vertical velocity is 0. Let's take a closer look at that initial velocity. Like we did with horizontal projectiles, we're going to organize our information in the table. Where does this 36 meters per second go? Is it VIX? Is it VIY? What do we do with it? Well, it's not vertical and it's not horizontal, so it doesn't go in either of those boxes. We have to figure out the components of the initial velocity. The horizontal component, VIX, and the vertical component, VIY. Once we've calculated these, we can put them in the table. Therefore, VIX will be VI cosine theta, and VIY will be VI sine theta. Let's start actually filling out this chart. 36 meters per second times the cosine of 50 degrees is 23.1 meters per second, so we'll plug that in for VIX. 36 meters per second times the sine of 50 degrees is 27.6 meters per second, so we'll plug that in for VIY. Just like in horizontal projectiles, the horizontal acceleration is 0 because there's nothing pushing it forward or pulling it backward, and the vertical acceleration is 9.81 meters per second squared. This time we have to call it negative though. Since the initial vertical velocity is upward and the acceleration is downward, we can't let them have the same sign. Finally, we can note that the final vertical velocity is 0. Here's what we'll call each of the boxes that remain. dx is the range, dy is the height, ty is the time up, and tx is the total time. You'll see that this time we've split the t row. This isn't to say that there's a horizontal time and a vertical time, but there's a time that we care about for the vertical motion and a different time that we care about for the horizontal motion. You'll see how this works. Let's calculate the height. We have enough information in the y column to calculate how high the ball ends up going. You'll see here that I've added y to the subscripts. You don't have to do that. I'm just doing it to make it clear that we only want to pick numbers from the y column, not the x column. When we plug in our final velocity and our initial velocity and our acceleration, we can find that the height that this ball reaches is 38.8 meters. Now let's figure out how long it takes to get to the highest point. Right, this is the time up. Here's our UAM equation. We can plug in our final velocity and our initial velocity and our acceleration, and we'll find that it takes 2.8 seconds to get to the highest point. If it took 2.8 seconds to go up, then it also took 2.8 seconds to come down, which means overall it took 5.6 seconds from the time the ball was kicked to the time the ball landed. We're going to plug this in as tx. Now let's figure out how far away the ball lands, the range. Once again, we'll use our UAM equation. You see this time that I have x in the subscript. We'll plug in our initial velocity and our acceleration and our time, and we'll find that the range of this ball was 129.4 meters. Let's talk about that final horizontal velocity. Since there is 0 horizontal acceleration, that means that the projectile doesn't speed up or slow down horizontally. This means that the final horizontal velocity is exactly the same as the initial horizontal velocity. So we could just plug in 23.1 meters per second there if we want to make sure that this table is totally complete. Okay, let's summarize. VIX is going to be VI cosine theta. VIY is going to be VI sine theta. VFY, the final vertical velocity, is going to be 0 meters per second. The horizontal acceleration is 0 meters per second squared. The vertical acceleration is negative 9.81 meters per second squared. And we're going to remember that the time up equals the time down.